Okay, so we kind of got way off topic here when we started talking about making bets. So now we're going to come back to arrays in this video here. So let's review what we know about arrays here. We know that I have 13 different variables I could use off of one program statement here. The first one starts from 0, the last one starts at 12. And the most important thing here, container 13 does not exist here. And the compiler will not tell you that. Like if you run this here, the compiler will not check to see if you're going out of bounds here. The last piece of the array is 12. So our first piece of the array starts at 0, and we just have separate variables here. Container number 7 and container 12 are two different variables here. And we can use them whenever we'd like. So we can have 1,000 variables here. Now we already know that we can initialize these to 0 by doing this. They'll all be initialized to 0 here. Now we can also initialize them like this: 2, 3, 5, 7, 11. So now right here we can do this here. Now the first 5, 0 would be equal to 2. The other ones would be equal to 3, 5, 7, 11. So from container 0 through 4 will be initialized to 2, 3, 5, 7, 11 respectively. The remaining containers will be initialized to 0 here. Now if I didn't have this at all here, they will not be initialized. So what if we don't want to just initialize them to 0 here? Well, I'm going to make a separate variable. Let's call it count. I'm going to start it off at 0. Now let's say while count is less than 13. We can do this. We can say count. We can say container. The container of count here. So this is this is something that's that we couldn't do before here. But we could increment this, like we can say count, container of count is going to equal 2 times count plus 1. And then we'll say count plus plus. Now let's see what happens here. Nothing will happen, but let's say we want to output all these values again. So we can say count. When we get out of this loop, we can set count back equal to 0 again. Now I'll explain all this in a second here. While count is greater, or is less than 13 again, I want to output the value of the container of count again. And I want to output a new line. So, and then we'll increment count again. Okay, so let's run this. So we go 1, 3, 5, 7, 9, 11, 13. Okay. So let's see what happens here. So we're not using this line of code here right now. Now first we declared 13 different variables, which are containers 0 through 12. Then we made another one called count, which is equal to 0 here. So first we're going to go through this while loop here. So count is equal to 0, so is 0 less than 13? This is a true statement. So we're going to go to here. So the container of 0, our first container, is going to equal to 2 times 0 plus 1, which is going to be 1 here. So our first container is equal to 1. Then we're going to increment count by 1. So now count equals 1 here. So now is 1 less than 13? It's true. So our next container, which is container 1, which is actually our second container, is going to be equal to 2 times 1 plus 1. So 2 times 1 is 2, plus 1 is 3. So our next one would be 3. Then we'll go to 2. So 2 times 2 is 4, plus 1 is 5. Then we'll keep on going here. Now when we get to count, when we get to number 12 here, we'll get, so we'll just say container number 12 is equal to 2 times 12, which is 24, plus 1 is 25. Then now count equals 13 here. So when we get to 13 here, this is false here, so we go to the next program statement. So count now equals 13 here, but it doesn't go in through this loop again. So we're not trying to access memory that's not there, because remember, count of 13 does not exist. Since count of 13 doesn't exist, we don't have to worry about that, because we know that it'll give the computer a few problems here, which can be annoying. But we can fix it. So then now, after we get out of this loop here, count equals 0. So now we do the same thing again. We're going through another loop from the same conditions here. We just output the containers. That's all we do. Okay. So and that's what happens. It just outputs the values of the containers. Now these values, you can come up with you can come up with any formula you want that that'll give all these values some value here. Now we could have also have done this. We could have got rid of this entire while loop altogether here. I just wanted to show you that you can basically do whatever you want, even if it's not efficient. We can output this in here. Container of count. And then we can end the line. And it does the same thing. It's all in one while loop, so we don't have to. The program's just almost twice as fast. Not that we're worried about speed right now, because these are so fast that you can't tell the difference between the programs that are running slow and fast. Okay. So what else could we do here? Let's say we delete this for now. We could have also have done this. We can initialize each one of them to this. 1, 3, 5, 7, 9, 11, 13, 15, 17, 19, and then 21, 23. We can make these whatever we want here. Let's just say we stop there. Now, let me bring that while loop back here. So these are just another way to initialize these. So 0 would be 1 here. Container 1 would be 3. Container 2 would be 5, and so on here. Now let's see. Let's just see if I'm right here. Let me bring that while loop back. So while count is less than 13, we're going to output container of count and line it. Now let's just see what happens here. Yeah, and I got to make sure I'm incrementing my count. Count plus plus. And notice we get all the way to 23, and then it goes to 0 here. Here, let me delete a few of these numbers here. So basically, these right here, they're all going to be initialized here, but I didn't initialize all of them here. I don't have all 13 numbers here. So the remaining 4 that I didn't initialize will be just set to 0. So everything will be initialized here. So we can also just initialize the first 2 here. 137, I guess, that's how it came out. To 137, the remaining ones would be 0 here. I can also just do this. I can just do the first one here. And we get 1, 0, or we can just initialize them all to 0 here. And now they're all 0. But if I don't have these braces here, and I try to output these things, these won't be initialized, and they'll be initialized to that negative value that happens to be the default value. So if we just wanted to initialize maybe we just wanted to initialize the 7th one here, we have to come outside here. See, when container, let's say we wanted the 3rd one here, container 3, which would actually be the 4th one. Keep that in mind. So that's going to be a little different here, and keep in mind that count. This one here, number 13, does not exist. You it'll cause your computer to complain. If you want to see what it looks like, go back to the video where I started talking about arrays. It should be called Introduction to Arrays. Say it's 7, and I get 7. That's it. Now, if I want to initialize them all to 0 here, I can easily. That's a shortcut, just to keep something initialized here. Alright, so that's that's what we got here on arrays. And I'm going to continue the discussion on arrays in the next video.